Let's go through LeetCode 149, max points in your line. So it give us a set of points and find the one line which has the maximal console point and return the point. So let's look at example 2. So you'll see we can have multiple lines. For example, this line, it has 4 points, and then this line may have 3 points, and probably this line has 2 points. So that maximum is 4, so we return 4. So anyway, we know we can have a map. This question we should have a map, right? So to store those kind of lines and its counts, right? So how can we store the lines? One way is that this line, we know a line should be determined by the slope and the interceptor. So if we have these two values as a pair, right, then we have the counts. So in that case, we for every 2 points. So for example, I equals 0, I smaller than n, and j is small equals I plus 1, and j is smaller than n, right? So we enumerate all of the points and calculate from I to j its slope and the intercept, right? And then compare the global max. But doing like this, the intercept, there is some issues. The intercept may not be an integer, right? Possibly it is an double, right? So it will lose some kind of, if we use use integer, it may lose some kind of um, accuracy, right? So, um, so the thing is that if we can avoid to calculate the intercept, or we just calculate one thing, the slope, right? Um, that will be better. So what we do is that instead of iterate all of the points and to calculate how many for one line, what is the counts, right? So we can iterate the first for loop is iterate the point from I equals 0 to n, right? And for this point, because the point is fixed, we have a map. Just the key will be the slope, and the value will be the counts, right? So in this case, for our we have local max. That is for this point, for this I point, what is the maximal local value? And we have a global max result. And every time we have a start point X, we try to find its max local max and compare to the max global max and return the global max, right? Um, Here, the question says that all of the points are unique. Um, so and we don't need to worry about those kind of 2 points that have duplicates. So let's begin to write code, some dummy code here right now. So we're going to have int n equals points dot length, and we're going to have a result equal to 0, right? So what we do is that for int I equals to 0, I smaller than n, I plus plus. So for this point, we want to have a slope counts. We have a map integer integer. Or about the key slope key, let's have question mark, right? We can what type it will be, and we call slope we don't know what is this type right now, right? Because slope map counts equals new hash, right? So what we do is that we iterate for int j equals I plus one, j is smaller than j plus plus. So how can we calculate the slope? We'll have, for example, int dx equals points j1, j0 minus the point I0, right? Int dy equals points j1 minus points I1, right? So for this dx and dy, right? So the things that if we have double, right? Double, that is the slope will be dy divided by dx, right? But doing like this, it may have some kind of accuracy issues because the double, right? We may not sure. So for double, we compare, especially when the data, for example, that is 3 divided by 7, right? Or there is another number is, for example, that is 300,001 divided by 7, something, right? 100. And it's hard for us to compare this case. We say it may be similar, right? So it's better we do not store double, right? So what we want is that we want to have store those kind of dx and dy, right? But the thing is that for the slope, for example, the 4 divided by 2, and the equals, for example, 8 divided by 4, right? So we cannot compare just dx and dy. We should um, divide those kind of dx and dy by their common GCD, common greatest common divider, right? So we should find, for example, int GCD equals um, we'll have a function GCD dx dy, right? And then we'll have dx divide, for example, this will be d, right? Divide equal to d, and dy divide equal to d, right? So this will be the pseudocode. And then, for example, our dx and dy, they already um, the after divided by the greatest common divider, those kind of dx and dy, they will be same, right? If the key will be the same. Um, then we'll see this kind of range is um, smaller, equal to is in this range, right? So we can have, for example, key equals dx plus, and then multiple by 2 plus dy, something like a dy plus like this, right? So that this will always be positive. And let's see, this is just like the transfer from matrix row column to I index, right? So we can use integer. This will still be in the range because that's 10 to the fourth, right? So that will be 10 to the eighth. And this range should be enough. Um, so we can have the key and value like this. So we know this map, we can have integer uh, of this, right? And the pseudocode will be something like this one. And we are going to have um, so 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 we are going to have the slope const merge key one integer dot sum, right? And then we iterate for this map for iterate this map for this point we have a map dot entry dot integer integer entry of slope const of entry setter. Then we are going to have uh, so we are going to have result equals max dot max result and entry of get a value, right? And we should also add a pointer I, right? So should add one, and in the end, return results. Right? So this will be kind of the code, but there is something we should consider. One thing is private into GCD, right? Into um, into A, into B. And if A equals 0, return B, right? And then return GCD uh, B mod A and A, right? So this will be pretty much like the code. Rather this will be it will pass. Actually, it pass. Of course, we should have um right. That's right. If A is smaller than 2, return A. Right. This will pass, but it didn't explain. There is some kind of hint, small pitfalls things, right? So here we'll see. One thing is that the dx and the dy, it's possible one of that it is negative. So in the GCD, right? GCD, if it is negative, it is possible, for example, using this function, using this function, using this function, for example, we have GCD2 and -3, it will return -1. And But if we have GCD -2 and 3, using this function is return 1, right? So, but for this function, it is possible that the there is, because the delta x and delta y, they may be negative, right? We didn't guarantee that it is positive, but it happened to get this one always to be the same sign, right? After dividing. The proof is a bit complicated. So in order to think about the negative, it happened to be correct doing like this way, right? In order that we don't have a negative things to affect this, right? So what we do is that we should compare if d we should have something like if dx, and how can we write? So if dx is negative, we should write if dx smaller than 0, right? Then we have dy should um, so we can have sign like this. Sign into sign equals dx smaller than um so how can we write this? So and dy greater than 0, or um dx greater than 0, and dy smaller than 0, right? Actually, doing like this is still not good. The thing is that because the dx or dy, if we should have three kind of scenarios. If dx, for example, equals 0, right? That means this is vertical. And also if dy equals to 0, right? That is horizontal. So we can use, for example, slope as -1 for vertical, or slope equals -2 to be vertical. And for the rest, we use the absolute value, right? Um, so in that case, for example, we are right. If dx equals 0, so we are going to have map slope count merge. For example, this we have here as -1 integer of sum, right? And I will say if else, if dy equals 0, then I have a slope counts of merge -2. For this key, right, it will always be positive. So 1 integer of sum. And else, that is we can put uh, something like this, right? And we need to make sure those kind of things in dx and dy, they are always be positive or not, right? So, what we do is that mm, our sign, for example, in the sign will be, for example, dy by mass dot absolute value dy multiplied by dx divided by absolute value dx, right? So 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 what we do is that we just have it's an absolute value of dx and mass dot absolute value dy, right? So we should have this. And we can write this. For example, x equals mass dot absolute value x, and y equals mass dot absolute value y, right? And then d will be um, dx, sorry, dx, dx. So it will be dx and dy, right? So this will always be positive. And let this dx and divide by this one, right? So dy could be equals dy multiplied by this. And if it is negative, let's put a dx always be negative and multiply by sign, right? So this will be, so that dx will always be positive. So we write code like this. So like this, we make sure that our GCD is always positive, right? And otherwise, that it is hard to explain. For example, dx is -2, dy, for example, is 3, and d, and another case is dx is 2, and dy is -3. It is actually when divided by if using this kind of GCD, right, it will convert to either to -2, 3, or to this, but it's hard to prove. So for this case, it's better we still use the absolute value to calculate this. And for the Python code will be very similar, right? So we're going to have n equals length of points, and the result equals to 0, right? For I in range n, and we need to import that dictionary. So what we do is that from collections import default. So we're going to have a slope counts equals if int. Um, and we're going to have for j in range I plus 1 to n, right? Then we're going to have the x equals points j1 minus points I1, right? And also dy this is dy, and dx equals points j0 minus points I there, right? So we'll say if dx equals 0, right, we're going to have key. Um, so so dx if we so we're going to have key equals -1, okay, and L if dy equals 0, then we'll set for example set this kind of key. The key equals -2, right? And then else, what do we do is that we're going to find the sign. So the sign will be dx multiplied by dy um, divided by gcd dx multiplied by dy, right? So we'll have dy equals absolute value dy, and dx equals absolute value dx. Then they are all positive, so we'll have d equals gcd dx dy, and then we have dy dy by 2. Uh, this should be slash equal to d, and we'll have dx should be dx divided by d and multiplied by sign, right? So this key will be um, this one plus 1000, right? The dy plus so actually this dy is always positive, right? So this dy if it doesn't add 1000 should be fine. But dx it is possible, it is negative, right? So we should have dy multiplied by something, 2, 1 plus dx plus 1000, 10,000, like this, right? And so we are going to, for this kind of case, we are going to have a slope counts p should increase by 1, right? And then for this point I, we should have for count in slope count of the values. We're going to have local max, right? Local max equals max local max and count and count, right? So for this kind of point, we're going to have result equals max result and local max. And then we should plus 1, right? Because we have a point I. And in the end, return result. So we can define RGCD here, right? DF GCD A B. If A equals 0, return B. Otherwise, just return GCD B mod A and A, right? So this will be the Python code. Yes, not GCD, ABS, right? Absolutely. Actually, we can just have result. Result. We don't need to have a local max, right? Result. We can just have result because result is on plus one. We don't need to have a local max variable. Because um, this is this one, and so if we are right, if a is smaller than 2, return and so doing like this, we'll see the time complexity will be because we iterate the point I, and for each point there are two for loops, so the time complexity will be O(n) square, and we have user map, right? This map is linear, so it will be O(n) space complexity. And for this question, it says that all points are unique. But the thing is that if we don't have this kind of question, right? So how can we do? Probably we can write this, right? So if um points I 0 equals points G 0, right? And points if we don't have a question, all the points are unique. So we need to have for this point find the duplicates. For example, points I one equals points J one, right? So we are going to have in the dupe variable. So this dupe initially set as 0. So if this case, we're going to have dupe plus plus and continue, right? We don't need to do this. And and then for this, we should have dupe plus this. Right? So as to compare with the global variable, so the change will be just add these conditions, right? So so this will be the code, and it is better that all of we put all of this A and B to be positive, to be absolute value, right? Otherwise, to prove that, for example, -2 and 3 and 2 -3, right? So you need to prove that, for example, this one has this one has comma divider, greatest common divisor to be 1, and this one has comma greatest common to be -1, right? So you need to prove that so that when divide, if you don't absolute value, the first time we submit, still be correct, but it's very hard to explain. Um, so this will be the code. So yeah, still it's better we have absolute value to put this out be negative, positive, and always put dy to be negative if there is one. The sign is different, right?